Here's pre-calc. This is problem 5-102. It says Anthony leaves Kingstown at 2 p.m. and drives to Queensville, a 160-mile distance, at 45 miles an hour. At 2:15, Helen leaves Queensville and drives to Kingstown at 40 miles per hour. At what time do they pass each other on the road? So this thing just yells out to me distance equals rate times time. So that's how I'm going to work on this problem, is by using my dirt prop, distance equals rate times time. So this little triangle tells me that distance equals rate times time. So I know that Anthony is going to be going this way, and Helen's going to be going this way, and they're probably not going to meet exactly, at the 80-mile mark, because he's going a little faster, she left a little later. So I'm just going to try to set this thing up. So here's where I started. I said, whatever the distance that Anthony covers plus the distance that Helen covers, that's going to add up to 160. It's probably not going to be 80 miles plus 80 miles. It's probably going to be something different than that. And I know that Anthony kind of had, his time he had a head start, or you could say he was already driving for 15 minutes before Helen left. So I wrote that Anthony's time, because, let's not make it confusing. Anthony's time is going to be whatever Helen's time was plus a quarter of an hour, because that's what 15 minutes is. And that's because he was already driving for 15 minutes before she left. So hopefully that makes sense, that his time is going to be her time plus 15 minutes since he started before her. So I'm going to swap out distance. We know it equals rate times time. So I'm going to say the rate times time of Anthony, which is the same as the distance, plus the rate times time of Helen equals 160. And the reason I did that is because they just gave us the rates. Like, here's nice rates right here. I can just plug them right in. So I just plugged in the rates, and then I already kind of have some little clue about their times. I know that Anthony's time is going to be Helen's time plus 0.25. So I'm going to do a little substitution. So I'm plugging in for T sub A. See T sub A? I plugged in T sub H, time of Helen, plus 0.25. And then now I've got, all I have to do is some algebra. I'm going to find out what Helen's time was. And then once I find out what Helen's time is, I can just add it to 2:15, and I'll know, what time it was when she met Anthony. So I just distributed, and then it turns out that 45 times 0.25 is actually 11.25, so I did that work. And then I subtracted 11.25 on both sides. That's an 11.25. And then I combined the 45 and the 40 to get 85, because those are like terms. And I divided both sides by 85 to get the T sub H by itself. And that gives me, I put that in the calculator, and it actually just came out to a nice clean 1.75. And at first I was confused, but then I remembered that's 1.75 hours. And that's like 1 3/4 hours. So that's 1 hour 45 minutes. And then all I have to do to find out what time it was when Helen met or crossed paths with Anthony is, I know Helen left at 2:15. So if I add an hour and 45 minutes, that makes it be 4 o'clock when they meet.